Good morning, everyone. Welcome back. In our previous sessions, we explored symbolic AI, rule based systems, and expert systems. And for a period of time, these systems looked revolutionary. Organizations believed intelligence could be engineered through handwritten logic. And honestly, in stable environments, that approach worked surprisingly well. But eventually, the real world exposed a major weakness. Static intelligence could not survive dynamic complexity. Now, this became one of the biggest turning points in artificial intelligence history because enterprises suddenly discovered something difficult. The world changes continuously. Now, think about modern enterprise environments for a moment. Customer expectations change, business rules change, cyber threats evolve, regulations evolve, supply chains fluctuate, financial markets shift. Technology changes rapidly. Human language itself evolves constantly. And every time reality changed, humans had to manually rewrite intelligence. Now, pause there for a moment. Think about the operational burden of that. Thousands of business rules, thousands of exception conditions, thousands of workflows, thousands of dependencies. Eventually, the complexity became overwhelming. And this created one of the biggest operational crises in early AI systems: rule explosion. Now, rule explosion was not simply a technical issue, it was an enterprise scalability problem. Because as organizations grew, their logic systems became increasingly difficult to maintain. Now, imagine a global enterprise trying to manually maintain intelligence across banking systems, insurance systems, compliance systems, manufacturing systems, government systems, customer workflows, and operational policies. The maintenance itself became massive. And another major problem also emerged: static systems could not adapt to unknown situations. This is extremely important. If something happened outside predefined rules, the system failed immediately. No adaptation, no learning, no contextual understanding, no flexibility, only predefined logic. Now, let me give you a practical example. Suppose a fraud detection system uses static rules. If transaction amount exceeds threshold, flag fraud. If geographic location changes, flag fraud. If login pattern changes, flag fraud. Simple, predictable, deterministic. But what happens when attackers evolve their behavior? What happens when fraud patterns become dynamic? What happens when customer behavior changes naturally? The static system struggles immediately because it only understands handwritten logic, not evolving behavior. And enterprises across industries started experiencing this limitation. Healthcare systems struggled with contextual diagnosis. Financial systems struggled with evolving risk patterns. Customer systems struggled with language ambiguity. Industrial systems struggled with unpredictable environments. And slowly, organizations realized something profound. Human intelligence is not static. Humans learn, humans adapt, humans recognize patterns dynamically, humans reason using context, humans improve through experience. And this realization fundamentally changed AI research forever. Now, from an architectural perspective, this was the breaking point between deterministic intelligence and adaptive intelligence. Researchers realized they could not manually encode knowledge forever. The world had become too dynamic, too complex, too unpredictable. And this realization forced artificial intelligence toward a completely new direction. Instead of teaching machines through handwritten rules, what if machines could learn directly from data? Now that question changed everything. Because for the first time, AI researchers began shifting from knowledge engineering to learning systems. And that transition became the foundation of modern machine learning. Now, before we close, I want you to recognize something important. Many enterprises today still contain layers of static intelligence underneath modern systems: approval workflows, business rules engines, compliance automation, legacy ERP systems, operational policy engine. Deterministic logic still exists everywhere, and understanding these limitations is critical because modern AI systems, especially agentic AI systems, are emerging specifically to overcome these constraints. The future of enterprise intelligence requires systems that can learn, adapt, reason, retrieve, verify, and evolve continuously, not merely follow predefined instructions. And that realization opened the door to the next great revolution in artificial intelligence, machine learning. Thank you, everyone. And I will see you in the next session.